Hi everyone, I am Lakshmi Biradar and today I am going to present my project on DDoS attack simulation and mitigation using Cisco Packet Tracer. This project demonstrates how a distributed denial of service attacks affects a new network and how we can reduce its effect using access control list, that is ACL, in Cisco Packet Tracer. Let's begin with the agenda. In today's presentations, I will cover introduction, objectives, what a DDoS attack, types of DDoS attacks, network topology, IP addressing, root configuration and attack simulation, and packet observation and conclusion. Now let's start with introduction. A computer network connects different devices so they can communicate and share information. Today, almost every organization depends on computer networks. As the use of networks increase, cyber attacks are also increasing. One of the most common attacks in the network is DDoS attacks. In this attack, multiple computers send a huge amount of traffic to the server, making it slow, unavailable for genuine users. This results in service interruption and downtime. Here are the objectives. The main objectives of these projects are to understand how attacks work and to design a network in Cisco Packet Tracer and to simulate attack traffic using multiple PCs and to implement ACL as a mitigation technique to observe the impact of successive traffic on the user. These objectives help us understand attack and defense mechanism. The remaining objectives are configure IP address correctly, allow communication between networks, block attackers' traffic, allow legitimate users to continue accessing the server, and compare the network behavior before and after applying ACL. Now start with what is DDoS. Definition: a distributed denial of service attack is a cyber attack where many computers attack one target simultaneously. Instead of stealing data, its main purpose is to make the server unavailable. The attacker sends thousands of requests simultaneously, continuously. As a result, CPU use increases, memory gets overloaded, network bandwidth becomes full, genuine users can't access the service. The main characteristics of DDoS attacks are very high network traffic, multiple attacker systems, service distribution, difficult to identify the real attackers, poor network performance. These attacks are commonly used to bring down websites, banking services, gaming services, and online applications. Now we start with types of DDoS attacks. There are mainly three types of DDoS attacks. The first one is volume-based attack. It floods the network with a huge amount of traffic and consumes all available bandwidth. Example, UDP flood, ICMP flood. The second type is protocol attack, which targets weakness in the network protocol and such as synchronous flood. The next type is application layer attack. These attacks target mainly web applications. They look like normal user requests, making them difficult to detect. Example, HTTP GET and POST flood. Here in this project I used ICMP flood where multiple computers continuously ping the server using the command, that is ping command, and this simulates DDoS like traffic. Now we start with the network topology. The network consists of three PCs, one switch, one router, one server. The PC0 acts as a legitimate user which sends normal requests to the server and continuously access the server even after ALS ACL is applied. The PC1 and the PC2 acts as attackers. They generate continuous ACM ping request, that is requests, and simulate DDoS like traffic directed at the server. The server is the target of the attack. The Cisco 2960 switch connects all the devices within the LAN, and the Cisco 2911 router connects all the LAN with the server network. The router also contains the ACL rules, and the server receives requests from the client computers. This setup is simple but demonstrates real network communication. Here we have one server which receives requests from all the clients and represents the target system under the attack. Now start with topology diagram. The diagram shows complete network, all three PCs connected to the switch, and the switch connected to the router, and the router connects to the server. During normal operation, every PC can communicate with the server. During attack, PC1, PC2 continuously sending ping requests. Later, ACL blocks these attacker systems. Now start with the working of a topology. The working process is very simple. First, packets are moved from PCs to the switch, and the switch forwards the packets to the router, and the router routes them to the server. When the attacker starts sending continuously ICMP packets, the network traffic increases. After ACL is applied, the attacker's traffic is blocked while legitimate traffic continues. Now start with some advantages. Like it is easy to understand, simple to configure, and demonstrate routing and switching concepts, and shows practical network security and suitable for educational purpose. Now we continue with IP address configuration. This allows communication between all devices. Each device must have a unique IP address. Here we using IPv4 version. The router attacks as the default gate, and proper IP addressing allows successful communication. Without correct IP address, device can't exchange the packets. Here in this table we can see that the IP address is assigned to every node, every device. In this LAN network uses 192.168.10/24, and the server network uses 10.10.10.0/24 IP address. The router connects both networks and forwards the packets between them. Now start with the router configuration. The router configuration enables communication between the two networks. We assign IP address to the router interfaces, and then we activate the interfaces using the no shutdown command. After this, the router is already ready to forward packets. The main commands used are enable, configure terminal, interface gigabyte Ethernet, IP address, and no shutdown, and exit. These commands configure the router interface. Finally, we save the configuration using write memory. After saving the configuration using write memory, we start verification. We verify the interface using show IP interface brief. If everything is correct, both interface should display up, and the green links in the packet tracer also indicate successful connectivity. Now here I explain how the attacks is simulated. Uh, in this project, a DDoS like attack is simulated using a continuous ICMP, that is ping request from multiple PCs. The PC1 and PC2 continuously send ICMP packets using ping request, and the servers receives a large number of requests, and these creates a DDoS like traffic. The purpose is observe network congestion. Start with the observation. In simulation mode, we observe different packet colors. The blue packets represent ICMP requests, white packets represent replies, and red packets indicate drop or a delay packets, and continuous packet movement, and shows heavily traffic network traffic. We can also see the impact of attacks, like server becomes slow, network congestion occurs, packet delay increases, possible packet losses. Here we discuss before security observations and after security observations. Before applying ACL, all PCs can communicate with the server. Attack traffic is not filtered, and the server receives requests from attackers and legitimate users. As the traffic increases, response time becomes slower and the network connection is clearly visible. After observing the simulation, the server becomes slow due to excessive requests and packet delay increases. Some packets may even be dropped. After ACL is applied, the attacker's packets are blocked while the legitimate users continues accessing the server successfully. This demonstrates the effectiveness of ACL as a basic mitigation technique. In this project, we successfully simulated a DDoS attack using Cisco Packet Tracer and reduced its impact using an access control list, that is ACL. And this project helps us to understand both network attacks and basic security techniques. Thank you. Now I will demonstrate the working of project. This is the network topology I created in the Cisco Packet Tracer. Here we have 3 PCs, one switch, one router and one server. Now I will simulate the DDoS attack. Here PC1 and PC2 are the attacker systems. Both attacker PCs I open in the command prompt and the type following command of the ping, and the -T option sends continuous ping requests without stopping. Both attackers PCs continuously send ICMP packets to the server. Though this is not a real DDoS attack, it effectively simulates the DDoS like traffic in the Cisco Packet Tracer. Now we will observe the attack in simulation mode. Now I switch Packet Tracer from real time and start simulation mode. Then I will click on autoplay, that is this one, and we can see the moving of the packets. Now we can observe the packets moving from blue packets representing ICMP echo request, while the white packets interpret the ICMP echo. So sometimes the red packets appear indicating delay or drop packets due to heavy traffic. Since we two attackers pieces are continuously sending the packets, the servers receives a very large number of requests. This creates a network congestion and increase in the traffic load. Beware of applying securities uh, mechanism. The routers allows traffic from every device. Both attackers and both attacker PCs and the regime can freely communicate with the server. As the attack continues, we observe continuous packet flow, heavy ICMP traffic, increase in the network congestion, and the slower response from the server. This demonstrates the impact of DDoS attack on network performance. Now we will apply the mitigation technique on the router, configuring that. Now we will apply the mitigation technique on the router, and I configure the ACL. The ACL blocks the traffic coming from the attacker's IP address, and after creating the ACL, I will apply the router interface. The router now filters incoming packets based on these rules. Now I run the simulation. Now again we run the simulation again. In this time the router blocks all the IPC packets coming from the attackers, and we can see that failed. And however, the PC0 is the legitimate user can still communicate successfully with the server. Here we can see that, and this shows the ACL effect blocks and unwanted traffic while allowing legitimate traffic to pass. So to conclude this demonstration, I successfully designed the network in Cisco Packet Tracer. So we configured the IP addresses and the router interface. So simultaneously we simulated a DDoS like attack using a continuous ICMP request, and we observed heavy traffic and congestion during the attack. So finally we implemented an ACL to the block attacker traffic. So after applying the ACL, the legitimate user could still access the server while the attackers were blocked. This demonstration is very simple but effective method for understanding the DDoS attacks and implementation basic network security using Cisco Packet Tracer. Thank you. This completes my project demonstration.